Greetings, this is Artie from Artifact Electronics. The purpose of today's video is to determine the power output, RMS wattage that this drives the speakers with, because that information is not available. The back of this doesn't tell you speaker impedance, it doesn't tell you what it's outputting. In short, it doesn't tell you anything. So we're going to have to make a few assumptions and then solve for the unknowns. What you see on the bench, these are all items that have been restored or fixed on this very bench. You can watch these videos. The easiest way is to go and click on the Artifact Electronics text down here. It'll take you to the home page, and on the home page all you have to do is click on videos, and it'll show you a reverse chronological order of all the videos made, including all of these guys. So to start off, our device under test is the Claricon 8-track player over here, which briefly, I don't think there was anything wrong with it other than the stereo light for FM reception. Next we have the Cronheit function generator, which got also worked but had extremely dirty controls, push buttons as well as pots that got cleaned. We have a Tektronix TDS340 over here that had a bad power supply, and the Fluke PM3370B, which had several problems. Now, in order to watch and enjoy this episode, you don't really need, a prerequisite is not to watch the videos for these. It's not really necessary to understand this, but if you haven't seen them, you should probably give it a chance and watch them anyway, because especially the repair on the Fluke was kind of interesting. The only other component we'll be using is this power resistor, rated at 25 watts with a value of 8.2 ohms. Since I'm going to make the assumption that this expects, that the device expects 8 ohm speaker loads, that's what we're going to use. My guess on power output is probably somewhere in the neighborhood of 5 to 8 watts, so the 25 watts should be more than sufficient. Now, to do this for bigger, for amplifiers that have a higher output, you should probably go out and get yourself some big wire wound resistors with a rating of 100 watts or higher. But I pretty much doubt that this thing is going to hit 10 watts per channel, if that. So this resistor, purely resistive obviously, is going to be simulating our speaker load. Now, an interesting point to note is that when you buy the wire wound resistors, they usually claim that they are non-inductive, and that's a load of bull, because anything that has a wire coil in it, not this one, this is ceramic, but the big ones that they sell on eBay, they have a copper coil inside of them. Anything with a coil is going to have inductance, so those should more properly be called low inductance rather than no inductance. But again, for our purposes, this resistor should do just fine. So how are we going to run this test? And well, I just noticed something looks kind of funny. For those of you snickering there, this kind of looks like, in the lower right, kind of looks like a big roll of toilet paper. It isn't. It's actually paper towels. But yeah, if you move the camera a little bit, it looks like I'm filming this in the bathroom. But back to matters at hand. Let's power up the scopes. They need some time. Especially the Philips one needs a little bit of time for the intensities, the screen intensities to normalize. But the way we're going to do this is we're going to use a 1 kilohertz sine wave coming out of here and going into an input on this. Now originally I was planning to use the, it has a tape input over here, which should be a regular line input, but it doesn't have any tape inputs on the back because this is where the tape input's coming from. So we're going to have to use phono. I don't know what the input sensitivity is supposed to be on this for phono. My guess is in somewhere around 100 or 150 millivolts. The phono cartridge itself usually has a range of about 1 millivolt or somewhere's there, but for consumer equipment, the consumer record players did have a primitive preamp in there to bring up the phono cartridge voltage, which was then fed into the amp. And again, that is something that I don't know, and we will have to empirically determine what that should be. Now the way, again, we're going to do all of this is we are going to turn the volume up all the way. We're going to put the 1 kHz sine wave in here, and we're going to adjust the volume until we see no distortion on the outputs, the sine wave that comes out. The lower scope is going to show us the input, the 1 kHz sine wave, and the upper scope is directly tied to the simulated load over here, and it's going to show us how much power is being output. We arrive at the actual power that's output, but the formula power is equal to the RMS voltage that's coming out of here squared divided by the resistance of the load. So that should be pretty simple, but again, first we need to determine of what amplitude to set the 1 kHz wave to in order to get as close to ideal conditions. We're going to try to max out the input while at the same time making sure that the input itself isn't distorted by the phono stage on the Claricon. Okay then, off we go. So let's turn the volume down on this, which means there should be no signal coming out here. No, that's not the power switch. This is the power switch. And we're set to phono, and just as described, we have an input, but nothing showing on the output, of course. Our input shows us close to 1 kHz, and just arbitrarily, the RMS voltage going in is 137 millivolts. Since we don't know what the numbers are, it's really this number, the absolute value of this number is actually irrelevant. So whether we show RMS or show peak to peak doesn't really make a difference. The main point being, we want to make sure that we're putting the maximum signal possible into this without distortion so that we can reach the maximum output power. And everything's hooked up. So now when we bring up the volume, we should start seeing the output waveform on this guy. Now we're hooked up to the left side, left input and left output, because I'm going to test this one channel at a time, and that falsifies things a little bit because when you're using both channels, there may be a certain amount of power supply sag introduced, which affects the power rating, but it's going to give us a nice ballpark figure of what this device is able of outputting. So first, to determine how high to set the input signal, and it's going to go hand in hand with measuring the output, and the way we do that is we'll just start cranking up the volume while watching for distortion over here. Oh, and I got to switch this to digital in order to see in order to see what it measures, and for some reason those measurements are gone. So what we got to do is turn on the frequency and the RMS output for this. So now let's move the volume up. Okay, we're at max. It won't go any higher, and it is not distorting. So the only way to fix that is we need to pump up what's going into it until this starts to distort. So unlike a lot of other tests you may have seen where they just pipe a signal into the amp and then turn the amp volume up until it distorts, well, at this input voltage level this amp won't distort. It's maxed out already. So we go to the amplitude on the function generator and increase the input until we start seeing some distortion here. So here's a little better view of the scope screens. So now I will go to the amplitude adjustment on the function generator and crank it up. Well, obviously we can see here it's hitting the power rail or the maximum output and distorting. So this is, we just got to turn back the input amplitude here. Bottoms look clean, but the top's kind of distorting a little bit. So I'm going to get this as clean as I think it's going to get. And we can see that it is now outputting maximum audio power, and if I touch the resistor, it is getting warm. Now it's only getting warm because it is rated at 25 watts. It's not too hot to touch or anything like that, but it is getting noticeably warm. So now if we use the formula of V squared over R, using this current RMS voltage that's coming out of the left channel, what do we have? We have 5.7, that's changing rapidly, so I'm just going to use 5.75, square that, and our load resistor down there is actually 8.2 ohms. So we're going to divide that by 8.2 ohms, and that gives us an output power of 4 watts. So this is saying that the left channel at max can produce 4 watts. Now if we crank the input, you'll see that the RMS voltage is going to go up. Because the tops and the bottoms of the sine wave are getting flattened out, there's actually it is actually generating more output voltage, even though more RMS output voltage, even though the sound is completely distorted. And to illustrate that, if I get some nice distortion in here, we can see that the output voltage rises to just above 7.5 volts RMS, but that's useless because it's distorting. And going back again. Okay, so now we're around 6 volts. So let's give this the benefit of the doubt again and see at 6 volts what the power output is. If I can use this calculator correctly. Well, this says it's 4.4 watts, so we're still at the 4 watt range here, which probably means it's rated, the This guy's rated at 5 watts per channel, and with all the years that have passed, component and the capacitor degradation and stuff like that, the power supply just is probably sagging at this point. But I think what that means is that the left channel, at least in here, is outputting, well, is outputting 4 watts in real life. So I went ahead and I plugged the 1 kilohertz input into the right channel and tapped the output from the right speaker output, and the balance was set all the way to the left on the amp, and I'm just going to move that over all the way to the right. Alright, so now we're looking at the output on the right side of the speaker, well, for the right speaker, and again adjusting the input. So obviously that's not very well balanced, because for the same input, the left channel reached its max output at a lower input voltage than the right channel does. And just for grins, 5.4 volts squared divided by 8.2 ohms, and this one tells us that it's 3.55 watts. So we're getting roughly 4 watts per channel, even though this thing is pretty unbalanced. But there you go. That's essentially the broad strokes in how you can measure the power output of an unknown piece of equipment. Of course, there's much more to actually measuring this, because there's total harmonic distortion you need to be aware of, intermodulation distortion, and just a whole bunch of things. Even though I kind of suspect that those figures coming out of this guy would be pretty poor, just seeing how unbalanced the 2 channels were with respect to each other. But at least we've solved the mystery of this beautiful piece of equipment, that it can output 5 watts. Well, thanks for watching. I hope this will give you a good indication, or a good roadmap on how to use a piece of equipment and check the audio output strength on it, or on a real amplifier, verify it if it's rated at 60 or 70. When does it actually start to distort, and when does it have enough headroom to actually distort when you're running the volume to 10 without having to go in and empirically determine what the input amplitude should be. But I think we're pretty. But the whole approach worked, and gave us a piece of information that I desperately needed. So go ahead, support the channel, subscribe if you haven't already, and we'll see you next time. I do need to add a quick postscript, and that is, my assumption was that the output impedance of this is 8 ohms. If it is 4 ohms, which was unusual for home stereo equipment, is more common for car stereo equipment, but that would give you a doubling of the output power, and our assumptions, or our empirical measurements, which point towards 5 watts originally, would instantly turn into 10 watts. Now, if we mismatch impedances between speakers and the output amplifier, all sorts of funny things are going to happen, and I really don't know what it is, but we would double the output power on a linear scale, but that doesn't do us a whole lot of good, because our ears respond to logarithmic changes in amplitude, and quite frankly, the difference between 5 and 10 watts, you would barely hear the difference in loudness there. But something to think about. Throw 4-ohm speakers on it and it'll roar.